So this should be a shorter chapter here, chapter 8, types of joints. I think there's going to be 2 lectures for these. Not a real difficult one, but you do need to know the differences between these types of joints and the important aspects of those. So I've already used the word quite a bit, articulation, and that basically just means a joint. It is a functional connection between bones. These connect the skeletal system, allow growth, movement, and adjustment to things like childbirth. Joints bind bones, allow bones to grow, and allow body parts to move. That's another way we can say that. They vary by structure and function and are classified by the type of joints that connect bones together. So be sure you know this slide. We've got structural classification and a functional classification, all right? And so we have 3 types of structural joints: fibrous, cartilaginous, and synovial. Fibrous joints are held together by collagen-rich, dense connective tissue. Joints are also classified by the degree of movement that is possible. Most joints of the skeletal system are going to be the 3rd type, which is going to be synovial. Okay, so fibrous, we said, dense connective tissues connect bones, and this is often between bones that are in close contact with each other. Cartilaginous joints are going to be formed of things like hyaline cartilage or fibrocartilage, and they connect bones together. And then synovial joints are what we typically think of as a joint. These are the most complex and allow free movement, like the hinge joint in my elbow, all right? And so then we have functional classification, which basically just describes how much they can move, okay? So synarthrotic joints are considered to be immovable, and so we wouldn't typically think of these as joints, but they are classified as joints. We have amphi like amphi or ambidextrous means multi, and so these are slightly movable. And then we have diarthrotic joints, which are freely movable, and those are typically the ones we think of when we think of the word joint. So we have 3 types of fibrous joints here, and remember, fibrous joints are synarthrosis. We have syndesmosis, suture, and gomphosis. Don't you just love those words? Syndesmosis are bound by connective tissue, and they articulate between things like between the tibia and the fibula. And so it's basically a type of interosseous membrane there as well, all right? And so you can see that interosseous membrane here. Okay, so here's the fibula, and I tend to say fibia, so please ignore that. I try to correct myself, but it just comes out that way. It's just so easy to say fibia and tibia. It is fibula, okay? And so here is this interosseous ligament here. And so the joint then lies between these and is amphiarthrotic, okay, partially movable. So the gomphosis is one of my favorite just because of that name, gomphosis, and it actually has to do with the gums, so it kind of makes sense. It has a cone-shaped body processed in a socket. So this is really, and you wouldn't think of this as a joint, but this is where your tooth is in your jawbone, and it is going to be synarthrotic, okay, synarthrotic. And is held there by a periodontal ligament. And you can see that here in this picture. You can see this periodontal ligament, all right? So a gomphosis is a fibrous joint formed by the union of a bony process and a bony socket, which is your tooth. So tooth that is attached to the maxilla or mandible, held together or held in by that periodontal ligament. And then we have a suture. A suture is a fibrous joint between flat bones of the skull. For example, they're almost like a lock and key. So this is where adjacent bones grow together in what we call a sutural ligament. Sutures replace fontanelles as they close. And it says teeth-like projections, and it just means like sawtooth. And so it's talking about this irregular line structure there, okay? Sutures in a lock, and so those are immovable. All right, so they are synarthrotic, immovable. So we have two types of cartilaginous joints, synchondrosis and symphysis. Syncrondrosis is where hyaline cartilage joins bones together. These are often temporary and disappear, kind of like epiphyseal plates do. You have bands of hyaline cartilage here that unite the bones together. This is temporary. At about 25, the ossification is complete, and the joint becomes a bony joint and is synarthrotic. Okay. An example of this is between the manubrium and the first rib of the costal cartilage. A symphysis is kind of almost like a joining, like we have the pubic symphysis that we can see here on the left. That's the best example here. It is a joint between adjacent vertebral bodies as well. It is amphiarthritic there. Adjacent vertebrae are separated by that intervertebral disc. So that is another example. And they act as shock absorbers, especially there, okay, in your spine. You really need some shock absorbing. Pubic symphysis allows pelvic bones to actually shift as an infant passes through the birth canal. And so there's actually some truth that because of hormones, you will have a loosening of that joint there, and the hips can actually literally spread out. So we tend to think that is fat, but it's actually the bones spread out a little bit, and they may not go back as close together as pre-birth, before the mother had the baby. And so amphiarthritic, slightly flexible. The discs are actually between the vertebrae are made of kind of a fibrocartilage, and they have a gelatinous gel-like core to them. So they're slightly flexible as well. So that's how they act as a shock absorber. Synovial joints, this is what we think of when we think of the word joints. These are freely movable joints, okay? Most joints are these. These are all diarthritic, which means freely movable. They have a joint capsule that is reinforced by ligaments that bind the articular or the ends of the bones that are articulating together. Bones of the synovial joint have that joint capsule that has a synovial fluid in it. That synovial fluid acts to moisten and lubricate the cartilaginous surface in the joint, so it acts as a lubrication, so it's very important. And as you get older, that synovial membrane that secretes the fluid, it doesn't function as well, and those joints get dry, and that capsule doesn't work as well, and that's where you can get arthritis in there, and you get bone rubbing on bone, and it can become quite painful. So the general structure of a synovial joint here, we have some specific parts. They are going to have an articular cartilage, a joint cavity, a joint capsule, synovial membrane, hopefully, and fluid, menisca, and a bursa. Articular cartilage helps to resist wear and decrease friction of the joint, and that is important. A meniscus cushions articulating surfaces, so it lies in the middle. So when we talk about your meniscus in the knee, it's a flat piece of cartilage there that lies in the middle between the two joints. It cushions those bones as they articulate. So we have what we call a bursa. This is a closed fluid-filled sac, and it also functions as a cushion. The knee here is the largest and most complex synovial joint that we have. We have several different types of synovial joints. We have condylar, ball and socket, hinge, shoulder. Ball and socket, the shoulder is an example. The rounded head of humerus and glenoid cavity of the scapula are examples as well. So ball and socket is a spheroidal joint, kind of a weird word. That's like your hip and shoulder joint, you know, that rotates around. You can see here in the picture, you can see the head of the femur there fitting into the acetabulum of the pelvis, and so it's really like a ball, okay? Then we have the condylar or it's a hard word to say, ellipsoidal joint. And that is like, for instance, your knuckles, when you pop your knuckles. Oh, did you hear that? Actually busting carbon dioxide bubbles there. These are between the metacarpals and phalanges, though, okay? Metacarpals and phalanges. So this portion is the phalanges, and so right here is a more condylar you can't see right here, joint, okay? You also find these between the radius and the carpals, okay? So carpals are here, carpals and then metacarpals. I don't know what you can see that. Carpals are what form your wrist. There's about 8 bones there, and then metacarpals. We also have plane or gliding joints and hinge joints. Plane and gliding joints are found between carpals, so between the wrist bones themselves. And so that's what part of the reason you can rotate and move your wrist all around is they articulate together between the tarsals and also between facets of those adjacent vertebrae. All right. Most of the joints in the ankle and wrist are going to be plane joints. Then we have hinge joints like our elbow. All right, and it basically works like a hinge. And I really like these little pictures here. If you'll look at these closely, to me, they really kind of illustrate how these work together. This one rolls in there, okay? Hinge joints are between the different phalanges. Next, we have a pivot joint or a trochoid joint. Pivot, and this is like the axis and atlas, where one pivots around the other, okay? So it's between C1 and dens of C2. And then we have the saddle or cellar joint, which is kind of interesting. And if you look at the picture there, that's really hard to describe, but it's between the first metacarpal of the thumb. And so that's one of the reasons we can move the thumb the way we can. But if you look at that, it kind of cups together, okay? It's like you have it fit together. It's actually a good way to look at it. It fits together like that.